Hey everybody, this is Larry. This is me trying to explain Q3 of the weekly contest 462, maximum total from optimal activation order. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, this one's very weird and tricky. I end up taking about 10 minutes, I want to say. And a lot of it is just reading. I suspect that a lot of people did not get this one just because of the reading. And I'm not saying it because, people don't know English or something like that. Because it took me, it's really hard to understand what the idea is, what the logic is, and so forth, right? The best way that I kind of think about it, honestly, during the contest, and I'm not saying that this is the best way to solve this one, because honestly, I don't know what the best way to solve this one is. But the way that I end up coming with it is just playing with ideas and then verifying it, right? Meaning that I was like, oh, does this idea work? No, okay, let's try another idea. The first thing is that n is pretty big, so we knew that there's probably a sorting component or some ordering component and a greedy component. You need one of those things to kind of make it faster than n log n, or as fast as n log n. I thought, honestly, during the contest for a while, I thought it was some kind of heap problem where I've tried to figure out the heap based on the limit, maybe sort on the 1 and the 2 and so forth. But the idea here, I think the core part is recognizing that and once I kind of phrased it in the right way, it was pretty simple to implement. I think the implementation was like less than a minute, maybe a little bit longer for testing and stuff. But it's just that if you have if the limit is 1, you can only choose one of the numbers. And then you start over again, right? So this is what this thing means, this line. It means that you wipe it clean and you start over again. So then kind of playing along with that idea is how I got that, okay, for each limit, you're able to get up to k, for k is equal to limit, number of numbers. And then once you reach that, you wipe them all clean. And in a way, all the limits kind of interact with each other, right? And having fewer is maybe okay. Yeah. And having fewer and not filling out is maybe okay. But yeah. But the rule set is very difficult to kind of explain, because once you hit the limit, only those limit goes. So for example, if you have a limit of 3, you do 2 elements, and then you do a number that's a limit of 5, and you hit 3, only those 3 go away, right? So you kind of swipe, you want to like start off clean in a weird way, but once you put it together and kind of put all the rules set in your head, and this is the way that I did it. So I don't know if this, it's not a great explanation, but that's just me being frank about, this is how I just had this idea of, okay, well, for every limit k, then that means that you could take k numbers and then kind of wipe them clean, right? And of course, within that, you want to take the max k of those limit k, right? And that's basically the way that I did it. As you can see, the code is pretty slim, and you don't even have to do it this way. You could probably do it with a heap, actually. But the way that I did it is just, at least for me, easier to understand. Because I was thinking about some sweep line along the way, but I was like, no, that's not even true, because you activate in a specific way, right? So for me, the way that I implemented is that for every L, for every limit, I give it its own thing, because it almost as if that all the limits don't matter because they don't interact with each other, right? The limit k for is an absolute limit for all the numbers with the limit k. So that's basically it. But it also means the other way, that if you have a limit k, you can always get k elements from all the numbers of that limit, right? Because all the numbers with k minus 1 would have swiped before, and then you remove, so then you always get up to k elements at limit k, right? So something like that. So yeah, so for every limit, I grouped them together, and then now for every key, we sorted. Though I guess sorting is not necessary, but the way that, yeah, sorting is not necessary actually, now that I think about it, but I just wanted to, I don't know, I just kind of did it that way, because I wanted to kind of uh, um, it's slightly closer to simulation the way that I wrote it, right? Because you're going from limit, from small limit to high limit, but it's technically not strictly necessary. But that requires a proof. But this is more simulation in my idea, so I don't know. Anyway, for every k that is sorted, we sort all the elements there. We reverse it so that the bigger numbers are in the front, and then for the limit k, we just make sure that we take the largest k elements, add it to the total, and then that's it. We just return it all to the total, and we are all Gucci. And yeah, that's it. Yeah, what's the complexity here, right? Well, this sorting, it makes it kind of n log n. And in the worst case, it will be. You can say maybe it's n log k for the max k if you put in a heap, but you could just put everything in the same thing and in a big limit, and that would be n log n. So yeah, and you probably could prove sorting things if you did. But in any case, though, but that's it. Yeah, I think this, like, if you look at this code, it's not. It looks too simple, but the problem is just so hard to read, to be frank. So, like, yeah, to be honest. So I don't know. It took me a while. But yeah, that's all I have with this one. Let me know what you think, and you could watch me solve it live in the contest now. Can't prove it honestly, or like not actively, but I just couldn't find a counter example. That's the TLDR. All right, Q3. Let's go. I don't know how I feel about that one. Okay. Optimal activation order. You have two arrays, value and limit, both length n. All elements are inactive. You activate element I. The number of currently active elements must be strictly less than limits of I. Okay. So you have to do this in kind of an order, sort of by the. When you activate I, the total activation value. Okay. After each activation, the number of currently active elements become X. What's X? What's X? What's X? What? Did I miss something? Is total activation value X? Leetcode does not edited problems, turns out. If the number of current becomes X, then all elements. Or maybe I don't get it. Okay, so if the number of currently active elements become 5, then all elements j with limits of j is less than or equal to 5 becomes permanent inactive unit. Okay, I mean, I guess that makes sense, but they shouldn't put it in like a variable x, like they highlight it as a thing. So it's very confusing, the notation. Okay, so activate 1. I mean, in this case, it'll be 1, 2, 3 makes sense, right? 5, maybe 5. It's just like a heap problem, this one, but feels like it anyway. It's just greedy on the heap. But what does it mean by permanently? Oh, so that means that limit is actually okay. I see. So because you have more inactive elements, so then now active is smaller, so then you can maybe do more limits. It's a really awkward problem for sure. And it's big. I mean, this is just heap in any case, I think, unless I'm misreading this one. But okay. The number of current active is it though? Maybe I'm wrong on this actually. And it becomes inactive, so then it's active. Okay. I mean, it is sorting, maybe not heap. And sorting would be based on an exchange principle. This one's a really awkward one, but I mean, these are good problems. I think they're like actual problems, maybe, even if the reading part is a little bit weird. That's the tricky part. But active after 1. Oh, but they become inactive. And because they become inactive, they cannot be activated. Okay. Is it greedy? This one maybe would take the 2. I mean, it is going to be some sort of greedy, but do you want to do greedy on active or? I mean, it feels like a sorting problem, but honestly, it's not. Or maybe a heap problem. How do you choose though? Sort by limit? You always want to sort by limit? No, I don't think so. Because you can have one that is, if you have something like limit 1, 1, and then you have like, I don't know, limit 4, 4, 4, 4, 4 limits, and then like, 5, 5, 5, 5, then you would just want to do all 4 5s and just ignore this one, right? So how do we kind of get this? Because otherwise, if you do these 4, then this gets the inactive, and then you just get like 6, you don't get enough points, right? But then on the other hand, if you do something like 100, well, no, let's just do 10, 10, 1. If you don't do it immediately, let's say you have 22, 10, 2 or something. This function is way weird, the active function. This seems like a problem that I'm going to get 5 wrong answers on. Because I'm going to use a greedy way, and I don't know how. Because here, well, I mean, even if you say 3, and I even say this is 15, you would, if you do greedy, you may do the 2 first, but then now this becomes inactive, and then you do this. But what you want to do is actually do this first, then this one, then this one, then you get all 3, right? There's this weird thing. This one I also don't know if I know, but maybe now it's okay to cheat on the timing. Oh, people got it fast. I mean, there are cheaters though, but some people, I mean, Lim Panda is most certainly not cheating, so that's pretty. Okay, so given the same limit, we definitely want to sort within the same limit, right? Then the question is, how do you do it? Oh, heap on the limit, huh? Heap on the limit, and then figure out how many you want to keep along the way. Okay, I mean, I guess. So then you sort by the limit, and then you just do it. Because then at the time you're at 2. Okay, so the reason is because when the limit is 2, you can only do. Also, I'm wrong on this one, because you would just do the 1 anyway, because it invalidates itself. So okay. So the ideal strategy is choose 1 from 1, 2 from 2, 3 from 3, and then so forth, and then sum that up. Okay. Okay, I see. It is a very weird problem, but okay. So then now we have 4 VL and zip value limit. Okay, yeah, that me constructing this example incorrectly kind of cost me some time, but that's okay. I don't think I really understood this problem anyway. I have to okay, we sort, reverse true. Technically, you could use a k heap, but I think that's it, right? It's a really confusing looking problem, but I think that's fine. F k sub I. Is it 16.6? Oh, I mean, I guess that makes sense. $16,612. YOLO submit. Okay, that one, it's kind of hard to read, but I see. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me in Discord. Let me know what you think about these problems, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.